we're picking up where we left off last Friday before we had a little extra time to finish our quiz. We already filled all this in. Where we got to was about to measure some angles. We don't need that. So this is where we were. This is not a good one. Oh, I got to get this thing. If I want to, I don't like this one as well as I like another one that's in here. Yes. Oh, okay. You get your protractor that I am lending you looks very much like this one. Okay, so what you're going to need to notice is right here. A lot of you have probably a little hole there on some of them, I think. It doesn't matter if there's a hole or not. But this, where the vertical line crosses, that's the right side of the protractor here. This side, you want to line your vertex up right here. Here's what I'm going to do. I'm going to take the protractor and pick it up, and I'm going to put it on C, the vertex of those angles. Now, is my protractor sitting correctly? What's wrong with it? You need, and this is what everybody needs to notice when they set one down, because this is the most common thing I see when kids are measuring incorrectly. They're not lining this up properly, just like I have not. You know, it's not going to be good for me to hold it like that. What I need to do is see 0 down here on the right, or the left is on the outside, on the right it's on the inside. I need to turn this so that the ray on the right lines up. Yes. Okay, you didn't understand when I said, were you gone on? You were here. You were here Friday. I did. You know, I don't know how that happened. Momento. Sorry. Okay, so sorry for the interruption there. All right, we've got to have our protractor lined up correctly. So again, this part right here, where the bottom, there's like a T, upside down T right here. That point where the two lines at the bottom intersect needs to go right on the vertex. Okay, now, I finally have it lined up, and I want to find angle ABD. Then I look for where ABD is, ABD, and I see that, wait a minute, one of the sides, BA, the ray BA is the side of that angle ABD. It's pointing at 20 degrees, so that's not right. So do you know what to do? Okay, I'll show you. Turn your protractor so that point A, just keep the vertex at B, keep that little cross where they intersect, those lines right here in the middle, or the little hole right there, and then point your A towards 0. The 0 should be on the outside, and that arrow should be right on 0. Okay, now I'm going to measure angle ABD by going from 0 on the outside here. I'm climbing up 10, 20, 30, 40, boom, and then I stop right there. That's where the arrow's pointing. How many degrees is that? All right, 45 degrees. We're supposed to classify our angles, which means we determine whether they're acute, obtuse, right, or straight. This would be acute. Okay, so that's how you measure that angle. That's what an angle is. It's an opening. We measure it in degrees. It's not a length. Okay, next I want to do angle TBC, and so I'm not lined up to do that. You have an option. Most students would prefer not to do this. you could. And then you could measure that one. And then I'd go from 0 out to here. So I don't think a lot of kids would do that. I think they would straighten it up like this. And let me show you how to read it when the arrow is pointing to the right. So if it's pointing to the right, I have to line it up towards 0 over here. You see 0's on the inside of this now? 0 is up right there on the inside. So I'm going to be climbing 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, and then I go in between 110 and 120. I look like about 115 then? Yes? Is it? Yeah, about 115. I couldn't draw on there. Is that bothering you? I measured this. But I came from the other side, the right side. So I had to read the inside numbers. And this would be obtuse because it's over 90. Oh, I forgot the T. Okay, I just blew spelling that like crazy. And I just erased a Q. All right. Obtuse, O-B-T-U-S-E. TBC. Oh, I think we can get that one pretty quick. We can read the inside numbers, and that's exactly going straight up to 90. All right, so that's a right angle. Is that all that we were supposed to measure on that page? Okay, so we went through 9. Just making sure this is right. Okay, 10. Now we have a completely different diagram. You can set the protractors down because we're not going to measure them. This is hard for a lot of students to look at and understand what an angle is. I'm not sure what it is, so I'm really trying hard to get you to understand what an angle is. It says name the vertex of angle 4. So you go where the 4 is, and you're saying, what angle? I don't see any arrows. Some kids do think that. This is angle 4. It has 2 rays that make it. You just have to think about them continuing on. So there is a ray that's going from B through A and from B through D that are making this opening right here. An angle is an opening. It's opening from there to there, which as it goes further and further out, it looks like it's getting wider, but the angle measure has not changed. So what's the vertex of angle 4? Well, point B, okay. Okay, next I'm going to name the sides of angle BDC. B to D to C. What sides make it? Well, this is one of them, and this is the other. The sides of an angle are rays. So this angle, B to D to C, you have to go in the order of the letters to determine where it's located. That opening is here. It's between ray DB and the other ray that makes that angle is ray DC. Every angle has 2 sides that are rays. Okay, now writing another name for an angle just requires me to either reverse the letters. So I could say angle CBD. Okay, and I didn't even have to look at the picture, and I named it another way. You cannot change where the B is, though. It must be in the middle. But I could go look for it, and if I went up to the diagram, and I went from D to B to C, that's up here. Angle 3 is another way to name it. We cannot call it angle B. There are too many other angles with the same vertex there. Or if you now it says write 2 other names for angle 2. So I go to angle 2, I see that it's this one. I'm going to go ahead and name it angle BDC. Okay. And then the only other way I can name it is to reverse the letters. Angle CBB. All right, and now name the sides of angle A. I haven't even got angle A highlighted at all up here. Angle A opens up here. So the sides of angle A are ray AB and ray A. It's got to start with A and it goes through B that way. So AB. Angles are made of two rays. A little confusing on that diagram, all those colors, but anybody still need this page? Angles that have the same measure are congruent. A ray that divides an angle into two congruent angles is called an angle bisector. So it makes two equal angles. That would kind of be the way I would think you would word it. In this figure, it says ray PN is the angle bisector. That's here. And these arcs here are indicating that those angles are congruent. The angle that has been bisected is angle MPR. Now, the interior of an angle, the interior of angle MPR, is in here, between the rays that make the angle. Those rays are ray PM and ray PR. And it goes on and on and on forever. Okay, that's called the interior of the angle. It says that point N lies on the interior. Well, it has to. If it's going to cut the angle in half, it's got to go on the interior. Okay, and it says point N is in the interior of angle MPR, and the angles that are congruent now are angles MPN and NPR. We're going to use these concepts now to do some setting up and solving. You need to go back. Okay. This is not on the notes, but a little aside. If I wanted to identify the pair of congruent angles in the diagram, I look at the markings. If they both have a single mark, that would make angle P congruent to angle N. And if they both have a double mark, that would make angle L congruent to angle M. Okay, so it's just, you can do different arcs, just like we did different numbers of slashes, name them. Okay, so what if measure of angle P was 120, then what would the measure of angle N be? It'd also be 120. Okay, you didn't have to write that down, I just wanted to remind you of how you might read the markings. Okay, so what we do have to fill in, we have some examples here of how you're going to use algebra and geometry together. It says if the measure of angle MPN is 2x plus 14, I look at the diagram, here's MPN, I'm going to label it with 2x plus 14. And the measure of angle NPR is x plus 34, I'm going to label that. It says to find x and find the measure of angle NPR. Well, how am I going to set up to solve for x? Go ahead. Good job. Yes. 2x plus 14. Oh, it was like you almost kind of lost your voice there for a second. I should know. Don't want to say the wrong thing. It's Chloe. I was right. Yeah, Chloe. Yeah, a little quiet, and all of a sudden you didn't come out, right? Okay, so we're going to set these equal because these angle measures are the same, being that we have shown these arcs right here. That means that the angles are the same. So x plus 14 equals x plus 34. And we subtract x from both sides. Oh. And then we get x plus 14 is 34. And then we subtract 14 from both sides. We end up with x is 20. But we didn't finish the question. So we got to make sure we get the measure of angle NPR also. So we got to plug it in. NPR is the one with the x plus 34 on it. So we're going to take and put 20 in there. Hi. Right there, hon. There you go. You're welcome. Good luck. You're welcome. Okay, so if I do 20 plus 34, that's 54. Cross country meet today. He left his bag here. Okay, now he answered the question. All right, number 16 says, in the diagram at the right, ray WY, that's this ray right here, bisects angle XWZ, which is the whole angle. That means these angles are equal, which is already marked. If the measure of angle XWY is 29 degrees, then the measure of angle YWZ is also 29 degrees. And it says to find the measure of angle XWZ. XWZ is the whole thing, so how big is that going to be? Well, it's the whole thing, so I got to put together these two angles to get the whole angle. 29 plus 29, which is 58 degrees. Okay? You got to know what you're reading here with the letters, what they're asking you for. Does it matter? Are we okay? I don't know what's going on, but oh well. Do we need me for anything, or are you just talking? Okay. 17. I hope that wasn't too bad. All right, now we got a busier picture. It says ray QP and ray QR are opposite rays. If they're opposite rays, that means that this is a straight angle. All right? That's all it's telling you. Next, it says ray QS, which is here, bisects angle PQT. Got to learn to follow the letters so you know what you're talking about here. If QS bisects angle PQT, then we know that angle PQS is congruent to angle SQT. So I marked it. It then says that PQT is 60. PQT is the whole thing. So from PQ to T, this measure is 60. These are equal, then how big are each? 30. Okay. So I can do that without even reading anymore. Then I can go, all right, measure of angle PQS is 4x plus 14. And we just said that that measurement is 30 degrees. So 4x plus 14 equals 30 degrees. Right? Now I just solved. And it said to find the value of x. So that's all we have to do. We've got 4 times x is equal to 16, and we divide by 4. Murphy. X is 4. And that's all you need to find. Okay, just a couple more examples, and you'll have some time to work on your homework. 18. Did anybody still need that? No, I went past. I don't. Okay, we got the same statement. QP and QR are opposite rays. That means this is straight. Then they're linear. They make a line. Ray QS bisects again. Angle PQT. Same thing as the last one, except something's got to be different. All right. So that means this is equal to this. If PQS, PQ to S, okay, that's 3x plus 13. You got to pay attention to where you are. You better start making sure you know how to find where the angle is. And the measure of angle SQT, go from S to Q to T, that would be this angle, 6x minus 2. Find the measure of angle PQT. So we're going to want to know the entire angle from there to there, and that's the question. All right, so we got to find x first. What shall we do? What do the hints give us? You guys, you're going to have to be able to think like this. This kind of thing is going to be what your quiz has on it and stuff. I asked, what should we do to solve the problem? Okay, set them equal. So what would I write then, Priscilla? Priscilla? What would I write then? Okay, so we're going to set those equal. Some students would like it better if we reversed that, like the sides for that. So I'm going to just write 6x minus 2 equals. Yours is totally fine, Priscilla. So 3x plus 13, correct? Way to set it up. Okay, I can tell some of you are listening. That's a good thing. All right, subtract 3x from both sides. And we got 3x minus 2 equals 13. Add 2. I'm just trying to help anybody who's struggling still with the algebra part by showing all the steps. You don't have to show every one of these steps if you know what you're doing. Or if you don't need to, you don't have to. 13 plus 2 is 15, and then you would divide both sides by 3 and get a final answer of x is 5. And then if this was a quiz, you'd be missing part of the answer. Because what did it ask for? All right, measure of angle PQT. Okay, so we're going to need to plug in the 5 back in here. 3 times 5 plus 13. Yeah, you need to go. Good luck in your math. 15 plus 13, we got 28 degrees, but that's only this part. Wait a minute, that's 28 degrees. So what's this one over here? Also 28, because they were equal. 28 plus 28, and we get 56 degrees. Okay. So it's not like really hard algebra in geometry class. It is, but it's the vocab that you have to know what to do to set it up. Okay, number 19. You know what the assignment is then, Darylyn? Nothing. I was talking to her. No, that's Dariana. You're Darylyn. I'm just still learning, guys. I have so many kids. Sorry. No, never mean to insult anyone. In the figure, ray BA and BC are opposite rays. Again, all that means at the bottom here is that since they're opposite rays, they form a straight line. Ray BF, I'm going to highlight that, bisects angle CBE. So here's angle C. What happened? Angle CBE is, oh, I don't know why I made that big of a mess, but I did. That's angle CBE. Ray BF bisects it, so that means it cuts angles and the angle in half, making angle 3 and 4 the same size. Okay, it says EBF is 6, E to B to F, that's this one, 6x plus 4. And CBF, that's this one, 7x minus 2. We're going to find EBF. We're going to set these equal again. I'd like to start with the one with the bigger x's, larger x value. So then I can subtract 6 from both sides, 6x from both sides, and then add 2. So I find out that the x is 6. I will plug back into the equations, or the expressions over here on the angles. 6 times 6 plus 4. 36 plus 4, we're going to get 40 degrees for that one and 40 degrees for this one. But what were we trying to answer? EBF. Did I already get it? Yeah. Angle. The measure of angle EBF is 40. That's the one I needed. EBF. Okay, one more example. Right? Or is that? No, there's actually 2 more. Okay, it's really not a whole lot new, except just setting it up again. This is ray BF. It is bisecting this angle, so that means angle 3 and 4 are congruent. I'm going to set those equal. 5x. Good luck. 5 times x equals 4x plus 10. There's a volleyball match. A lot of stuff today. Subtract 4x. We have x is 10. Okay, now wait, where was that stuff? This was your 5 times x. This one was your 4x plus 10. And then it wants me to find the measure of angle 4. Oh, okay. 5 times 10. So that's going to be the measure of angle 4 is 50 degrees. Okay. All right, wait, is there 21? It jumped. All right, what do we got? We got same thing. BF bisects angle CBE. There's extra stuff in this picture we haven't been using at all. We got 6y plus 2 for angle EBF, and we've got for angle 4, 8y minus 14. They are equal, so let's start with the larger amount of y. 8y minus 14 equals 6y plus 2. Subtract 6y. 2y minus 14 equals 2. Add 14. 2y equals 16. Divide by 2, y is 8. Then find the measure of angle CBE. That's the whole thing. So we got to plug in 8. 8 times 8 minus 14. That'll be 50. 6 times 8 plus 2 was 50. And I agree. I had some kids say to me, well, Ms. Heimer, that doesn't look like it's 100 degrees because the whole thing is 50 plus 50. And you're right. Angle CBE, according to what we solved, is 100 degrees, but that is not to scale. So oftentimes some of our diagrams are not going to be to scale, right? That is not an actually 100 degree angle in the picture. Okay, I think that was it. Now the homework part, that's what you got on the podium today. You got some examples to try to follow to help you practice. I'm going to answer a couple of questions in here, and then you can ask me more if you need. But just to get started, The vertex, that would be the corner point where the angle is. So if I was going to angle 4, that's going to be point P. Angle 4 is this opening right here. Its vertex would be point P. Stuck. My pen's stuck. So you just write capital T. But what about angle 1? That would be point W. You just write the capital letter if you like, or you can write the PP in front of it. You're also going to need to find the sides on angles, and this is one that is the most missed question on the next quiz. The sides of angle 4. The sides of angles are 2 rays. Oh, lovely. 2 rays should have 2 answers. So if you're going to go to angle 4 and tell me what the sides are for this opening, that would be ray CU and ray CS. Okay, can you clarify what you mean by it? Does it matter what order? No. So that does matter. So good question. You cannot name a ray. You have to tell what direction it's headed. Okay? So it's got to be the vertex and then a point on the ray. Caden? Number 4. Okay, 1 second. I didn't go over it. I'm not doing all these for you. What would be the answer to number 4? You're just trying to tell me what the vertex point is. Okay, wait. Look here. Angle 5. What is the middle letter for angle 5? You don't know what I mean. Okay, we got to get that figured out. Okay. Yes, it's T. This is the angle 5. This is the inside of the angle. Go to the corner point, which is here. That's your point T. Okay? Is that what you needed? What was okay, I want to get this straight. What is the corner point for angle 2? And do you see angle 2 where the 2 is labeled? That is the inside of the angle. That's here. So that's point D. Is its vertex. Angle 2 goes that way. That's angle 2. That was a mess. A lot of kids get confused by where the angles are, so that's a very critical thing for us to talk about in the beginning. I just wanted to remind you that these have 2 answers for 5, 6, 7, and 8. Someone have something else they want help with right away?